Golden box of knowledge. Okay, I really thought this was going to be on last year's test, and it wasn't. So I'm banking on it being this year, because there's usually always one justification, and it's usually one of the theorems or definition of continuity, and then one year they surprise us with squeeze. So it kind of depends on the test. They haven't done continuity in a long time, so I'm thinking it's going to happen this year. Okay, so for this test, or like to prove it, you have to do the 3 steps. So the first one, I think, is probably the easiest one because you just plug it in. And then the second step is the most annoying step because you have to do like all the stuff. So you have to like do the limit, but then a lot of the times you have to prove like, what's the left limit? What's the right limit? Now they equal. So the limit exists. So step 2 is annoying. So as long as you accept that as part of life, you'll be fine. And then the last one is like the juice, because this is saying, okay, step 1 and 2 equal each other. And you need this exact thing here in order to like prove it officially. So these are all your different discontinuities, which we kind of talked about. This infinitely oscillating one, that was like the sine of 1 over x. Is a infinite. That's what that graph is. I think it's that one. Yeah. For that. Continuous composite functions. If like f and g are both continuous, their composite is. So that one's kind of intuitive. So I think that'll be good. All right. So we're just going to practice justifying these. So is the function continuous? Justify our answer. If it's discontinuous, what type of discontinuity it is. So for these steps, and you have to be like super, super good. Okay. You can number them. But the first thing you need to do is do f of, and then try to check that nothing's going to be a discontinuity. So like here we have a line and a parabola. So those are in the clear. But things could hit the fan at -3 because they change, So maybe the line doesn't meet up with the parabola nice. So what you're going to do is you're going to check the -3, what's going on there. So the way you write your work is you have to tell the grader that you're plugging -3 in for f. And then you can plug it in the equation. You can't just start plugging in the equation without telling them what you're doing. So you have to be like, I'm plugging -3 in. That means I'm going to plug it into the parabola guy and get the answer. Okay, so what is that? -3, right? So you get that. So that's step 1. Step 2, okay, is the most annoying. You have to do the limit stuff. Okay, so you have to show that the limit exists at -3. And what is it? So, bless you. Because we're dealing with like different functions on different sides of -3, we're going to do the left and right limits. Make sure you write f of x in here, not the equation. So wait, where's my... Come on. Dry blood. This is death. Ready? The death is if you, wait, from the -3, that would be if you plugged in this. Okay, that's really bad. So don't plug in the equation. We're talking about if the piecewise is continuous or not. You can start like making sure you're getting it right by using the equation once you plug in the -3 plus 5 equals -1. Okay, so for this one, usually the AP is fine stopping here. But like technically it doesn't satisfy the second step. So you could say like you could do -3 from the right of f of x, because we've already done that on step 1. Okay, so we've already plugged it in, the 6 minus x squared. So then you can say the reason it's not continuous is since the limit doesn't exist. Okay, so for step 2, it's failed. Okay, so the second you get to a step that fails, you can say it's not continuous. So like in step 1, if it didn't exist, you could be like, not continuous, done. You don't have to go through all the steps. So the way you would explain this is you would say, since the limit as x approaches -3 from the left doesn't equal the limit as x approaches -3 from the right, okay, therefore the function is not continuous. So you don't have to go through all the steps. And you might see some questions like this on your test, by the way, on FRQ. Question is not where you have to do all this justification. Okay. So the second you get to a step that doesn't work, you're done. Okay. All right. Oh, do you know what kind of discontinuity this is? Yep. Jump. The takeaway is it's jump because these, you have -3, and then from the left you hit -3, but then all of a sudden you're at -1 on the right side. So when you have different numbers here, that's the idea for a jump, because you're getting like 2 different y's at the same spot. If that makes sense. Okay. All right. Another type of question is, like this is just a multiple choice, obviously, no calculator. We have a function where c is a constant. For what value of c, if any, is f continuous at x equals 2? Honestly, even without reading it, you could just kind of be like, well, x equals 2, so you could just plug in 2 and then see what happens. You know what I mean? So for it to be continuous, we want these two to equal each other. So what you're going to do is just plug 2 in for x, yx, because it says x equals 2, right? So you're going to go like 2 squared, squared sine pi times 2 equals 2 squared plus c. What? Oh, that, but it'll be fine because now we can do algebra for it. So plug in all your 2's and then algebra it out, and then you should get the answer fine. So what is this for? Sine of 2 pi, 0, 4, 2c minus 18. So then we get, was that -14? So 14 equals 2c, so 7. A. For part like D, the way they'd mess you up on D is, oh, actually, never mind. If there's no such value of C, you would get like things not equaling each other, or like it does not exist as you're solving. All right. Oh, this is supposed to say discontinuity. Okay, so to describe the discontinuity, honestly, a lot of the times this one's multiple choice. So you have to decide if it's removable, infinite, asymptotes, that kind of thing. So basically what you do is you like mess around algebraically with it. So like do all your factoring, and then see if there's like holes, like removables that divide out, all that business. So what is this? -3, x minus 1. Okay, so nothing like divided out, you know? So there's no removables, but remember with our limit stuff, there's going to be asymptotes because of that. So this one's going to have some asymptotes here. So we have an asymptote at x equals 3 and x equals 1. So then the way you call that, that would be called infinite discontinuity. So why don't you guys just do the second one? It's kind of the same-ish. check with you people. Okay. All right. So always factor removable because they divide out. Okay. So that's a removable at x equals 5. All right. So that's continuity. I didn't do one that was actually continuous. We'll do one as a warm-up tomorrow. But it's basically you follow the full steps with that. So you would keep going to get all those down. Intermediate value theorem, you just have to make sure you're justifying correctly. This is like the chicken and the road problem. So it's basically the chicken goes from point A to point B, and you have to decide if it's going to cross the road, where the road is. Okay, so this is like this stupid way to remember it. If anyone feels artistic, you should make a ceiling tile about the chicken, you know? Wouldn't that be fun? Okay, so anyway, so F is continuous. So when you're justifying, okay, you're going to have to say this, okay? Then you're also going to have to say this, closed interval, okay? And you're going to have to say this between business, okay? You're going to have to say this between business. Usually I use inequalities for that, okay, because I don't like writing. That's my only thing. And then you have to say this exact sentence. So it's like kind of obnoxious, okay? So exists another C. So I'll help you like color code all the stuff, okay? So basically intermediate value theorem is the chicken, okay? So chicken. Okay, so if it's continuous function on the interval, so what that means is like chicken starting here, ending here, chicken starting here, ending there, chicken starting here, ending there, okay? So there's your chicken. So you're going to have 2 endpoints. That'll be your interval. And then they're going to tell you where your road is, okay? So your road... what color I want to do for road? Guess we'll just do black for that. I'll do orange. How about? So now you have to figure out where your road is. If your road is here, it'll be like some number. Or sometimes they do zeros to talk about the axes. Okay, so do the x-axis. So this is where your road is. This is where your road is. They're saying you're going to cross it at least once. Okay, so going from point A to point B, the chicken's crossing the road. Okay, so when you're reading these questions, okay, the things you have to be like really diligent about, because they are mean on multiple choice with this at least, is you need to look for continuous. Okay, you have to, because I've seen them where they just say, here are values of f of x. And then they don't say continuity, and they can get you on that. Okay, so it's continuous, so that's good. The other thing we need to check is that there's an interval. On a table, you can assume it's an interval because it's like ends, you know, like you still have ends. So here, this is good. Oh, just kidding. They wrote it on here, the interval. Okay, so we have an interval. The parentheses versus the brackets isn't as big of a deal, apparently, to them. So we're just kind of going with it. Okay, and then between f of a, so those are those 2 values, there exists a number c. Actually, maybe I'll do that in purple because that'll be that exists the number. So you need to figure out if this, okay, this is like your y equals 5, you know, that's where your road is. So this is your road. Okay. So if you need to, like, you can draw a picture of this to see if that's going to work. Okay. So you can draw a little pic, draw your road. Road's going to be at 5. So here's your road. Okay. And you need to get where the chicken started and ended. Okay. So the chicken started at x equals 0, 7. And ended, well, 4, -6. I don't even need to go to -6. Oh, they're talking about interval 0 to 2. So I guess we're going to focus on here instead of the 4. So 0 to 2, and then it's going to end at 3. So 2 comma 3, it's going to be here. Now, because it's a continuous function, it means it's going to cross. Okay. So the way you justify that, so it'll cross at least more than once. Keep in mind, it can be a wild chicken. Okay. The chicken is wild. Okay. But it could be continuous. Okay. So now, as far as if it applies, okay, you would say, yes, it would apply. And this is how you would explain it. So you would say, since, so you basically are following that little box. You could say, now we're talking about G, not F. Okay. So since G of X is continuous, okay, and then we have to say it's continuous on an interval, okay, on the interval. Now, they're talking about 0, 2. I don't know why they're giving you 4. That's just kind of annoying. But on the interval 0, 2, brackets or parentheses is fine. Maybe I'll just do brackets. Okay. And, okay, so we did the interval part. And now you have to talk about the between thing. Okay. So you can say it's between, like you can use the words. You usually see it as like inequalities. So, and you would say, okay, so what's 5 in between? Because road is the 5. Okay, it's between G of, so the smaller one is at 1, or no, 2. And the larger one is at 0. So I'm saying, I'm not saying it's between 7 and 3. I'm saying when I plug in 2, that's the smaller number. When I plug in 0, I get a larger number. Okay, it's between there. And then you say, therefore, by the intermediate value theorem. Okay, and this is where you have to say that there exists thing. There exists a value. Now, this is where you say like C, or it's going to cross at some time. This one, their value was R, a value R, such that f of R equals 5. That f of R represents these, like where it intersects the road. So that's like the perfect exact way you have to justify it. Is there any questions with that? Okay. We're going to do a couple more. I know, we'll be okay. Okay. So here we have a piecewise, which you're always like, oh, these dang piecewises. There must exist some value x between 0 and 2 for which blah, blah, blah. Okay, so the first thing you check. So this one was perfect because it had all the junk. So the first thing you check is if it's continuous. Cool. They didn't even tell me. Ugh, I hate proving continuity. Continuous? I don't know. Got to figure it out. I don't know. Okay. So you're going to have to check continuity. Okay. They're talking about a value between 0 and 2. Perfect. 1 is where the, things can hit the fan, right? You might hopefully look at that and already know if it's continuous or discontinuous. You see, they're both lines and they have different y-intercepts. You know what I'm saying? So, like, if you were going to prove it, like, perfectly, you would go through the steps, which is annoying because you probably already know the answer. But you would plug in, it's not F, it's K. K of 1, get your answer 3. And then your second step, you can show that the limits don't match. Of K of X, and then the limit as X approaches 1 from the right of K of X, So from the left was 3, and then the right was 5. So then you can be like, because they're, since the limits don't match, well, I guess I'll write that first. And remember, like, do I like writing all this? Of course not, but no one cares about my opinion. You know what I mean? It's just how it is. So you just have to suck it up, and write it anyway. Okay. So you're going to write it, and then you say, so it's not, because it's not continuous. So you don't even have to do the whole shebang with intermediate value theorem. Okay. So if it was a justifying piece and you had to prove continuity, now you're going back to this junk. Do you know what I'm saying? So the justifying is what kills people, I feel like. I don't know. All right. So I don't know. Do you think you can try this one? I think you can do this. Now you have a function. So like, okay, you don't have the y's. Do you know what I mean? You don't have the starting and ending points for the chicken, but you can figure it out. Okay. So try to do it and justify it perfectly. Ready, go. Okay, working on the second one. There you go. Okay. No, because it's a polynomial, so you don't have to. Yeah. Nice. You don't have to prove continuity because it's a polynomial. So you can assume it's continuous. Okay. Use the same sentence structure that I did. Do you know what I mean? Like, nice. Good. Perfect. Everyone look at his. That one. Okay. So I guess I should have said this before we had started, but if they give you an equation, you can assume it's continuous because if it's like a polynomial or something, or if it's like sine, you could kind of say like it's continuous because you know that about the function. And then as far as the between, if you plug in 0 and 1 into the function, you get 0 and 6. So it worked because since S is continuous on the interval 0 to 1. So don't do anything besides this. This is exactly what you write. Okay, you can't do like little makeshift justification. Okay, so since it's continuous on the interval 0 to 1, and this is the between thing, by the inner value theorem, there exists a value A. They said A such that S of A equals 3. Okay, is there any questions with that? No. Okay, I don't think we need to do that one. Maybe. Why don't you guys think about this last one? Try to answer those, if that's true or false. Because these are these multiple choice that try to mess with you all the time. Draw a picture if it helps. Try to think of a counter example that proves it false. If you take a logic class and know all the rules, it'll be very easy to do this. But okay, because A is false. Okay, I don't know if you got that. That's false. Okay, if it's not continuous, there's no value C for which f of C equals 7. Well, it didn't say where it was not continuous. So technically that could happen. Okay, because it could be discontinuous like early on in the chicken's trip. You know what I'm saying? So like there could be some discontinuity happening before. This one, if you've got the values, okay, and there's no value where it equals 7, then it's for sure not continuous. Okay, so this is actually for part B, this is the contrapositive. Do you remember that from geometry? Because you did a little bit of logic in geometry, but this is the contrapositive of the statement. They switched the if-thens and negated them. So those are logically equivalent all the time. So there's a little logic lesson in there for you if you'll get a math minor. So there you go. That is it. So I tried to